Fusion Mobile, quality e-learning experience on the go.
My dearest, I'm glad you're back. Now let's discuss current electricity. This is the branch of physics that deals with the moving charges. A current is any motion of charge from one region to another in an electric circuit. But in a more mathematical definition, we can say that current is the quantity of charge that passes through a conductor per unit time. I repeat, current is the quantity of charge that passes through a conductor per unit time. Mathematically, it is given as current, which is represented with I conventionally, equal to quantity of charge, Q, divided by time. The SI unit of current is amperes. We have current measuring instruments such as ammeter, the micrometer, microammeter, the milliammeter, and also the galvanometer. Potential difference. Between any 2 points in a circuit, you can define the potential difference as the work done in joules when one column of electricity moves from one point to another. It is measured with a voltmeter and the SI unit is in volts. Another way you can define it, you can say that potential difference is the work done in taking a unit positive charge from one point to another within the field. Resistance. This is an opposition to current produced by the electrical device known as resistor. Ohm's law. Ohm's law states that the electrical current passing through a metallic conductor at a constant temperature is directly proportional to the potential difference applied between its ends. In another way, we can redefine it as, or say that Ohm's law states that the current passing through a metallic conductor is directly proportional to the potential difference across the conductor as long as every other physical parameters remains constant. Let me take you back to resistance, majorly on arrangement of resistance. There are two basic ways which resistors can be arranged. The first one is the series arrangement. In series arrangement, we may have three resistors in this form, and they are placed 1, 2, 3, such that the same current I is passing through them. Once the same current is passing through resistors, we'll say that those resistors are in series. And the mathematical formula to take care of this says that the total resistance R will be equal to R1 plus R2 plus R3, depending on the number of resistors given to you. This is series arrangement. Example, if R1 here is 2, if R1 is equal to 2, R2 is equal to 1, and maybe R3 is equal to 1, and I'm asked to calculate the net resistance or the equivalent resistance or the total resistance, all mean the same. As long as they are in series, my total resistance R is equal to 2 plus 1 plus 1, which is equal to 4 ohms. Ohms is the SI unit of resistance. I can now take us to parallel arrangement of resistance. Remember, we said there are 2 basic ways which we can arrange resistance, and we say the first one is series arrangement and the second one is parallel arrangement. In parallel arrangement, for example, if I have a set in this form, these are 3 resistors, like the first one, 1, 2, and 3. But this time around, they are in parallel. Why are they in parallel? If I consider this to be my current, at this point here, the current will split. Some will go to R1, some will go to R2, and some will go to R3. The mathematical formula to take care of this says that the inverse of the total resistance, 1 over R, is giving us 1 over R1 plus 1 over R2 plus 1 over R3. See, if I'm handling that problem we solved before on series arrangements, here, if I'm handling this problem where we have R1 equal to 2, R2 equal to 1, and R3 equal to 1, that means what I will now work on is 1 over R will be equal to 1 over 2, or 1. That's 1 over 1 plus 1 over 2 plus 1 over 1. That means that 1 over R will be equal to, taking the LCM, we have 2. Here we have 2 plus 1 plus 1. That means 1 over R is equal to 2 plus 1 is 3, plus 1 is 4. We have 4 over 2. So, if 1 over R is 4 over 2, which is the same thing as 2, that means that R will be equal to the inverse, which is what? 2 over 1, which is 1 over 2, which is equal to 0.5. This is the way you can solve your problem when it comes to arrangement of resistors. Now let's leave resistors and move over to cells. Electric cells. A cell is a device for converting chemical energy to electrical energy. Types of cells. In types of cells, they are grouped. According to the red strokes, we have the primary cell, we have the secondary cell. Another name for secondary cell is called the accumulators. Under the primary cell, we have the Leclerc cell, which is, we have the wet and the dry type, the Daniel cell. Then here we have the lead acid accumulator, the alkaline accumulator, and the knife accumulator. Then we come over to defects of a simple cell. There are 2 major defects of a simple cell. One is polarization. This is due to the production of hydrogen gas bubbles around the copper plate of the cell. This is due to the reaction of zinc and dilute tetraoxosulfate 6 acid. This reaction sets up a back electromotive force which reduces the current in the external circuit. Polarization can be reduced by brushing the plates well, or by the use of a depolarizer such as manganese dioxide or potassium dichromate, which oxidizes hydrogen to form water and so removes the hydrogen bubbles. The second problem of a simple cell is the local action. This is due to impurities in the zinc plate, which results in the wearing away of the electrode. These impurities, which can be iron or even carbon, set up tiny cells around the zinc surface, producing bubbles of hydrogen. Zinc plate is being dissolved and washed. Since no current is supplied to the external circuit, local action can be prevented by amalgamation. By amalgamation, we mean cleaning the zinc with tetraoxosulfur acid and then rubbing it with some mercury, which covers up the impurities and prevents their contact with the electrolyte. Arrangement of cells. Cells, just like resistors, can also be arranged both in series and in parallel. In series arrangement of cells, as the diagram here shows, we will have a mathematical formula which will give us that the total cell E will be equal to E1 plus E2 plus E3. But in parallel arrangements, it's not the same. Whenever cells are arranged in parallel, it simply means that the total cell will have the same value as each of those cells. Example, the diagram here, parallel circuits, we have it that E total will be equal to E1 and will be equal to E2 and also will be equal to A3. That is parallel arrangement. The total EMF will be equal to one of the EMF given, while in series arrangement, the total EMF is the sum of the EMF given. The next thing we will discuss is the particulate nature of matter. We are gradually moving into physics deeper. My dear, I hope you are enjoying the program, learning with ease in your own conducive environment. Thank you. See you in that class of particulate nature of matter.